Well, we've came quite a ways. We are now fully numerate, which is more than can be said for a lot of students, and in fact, a lot of teachers for that matter. And as being fully numerate, we are able to represent numbers with symbols, with the word that we would speak, and with also the object representations. And we can do that interchangeably. Now, we've done comparison earlier, and we got to comparison by asking question, which is larger. We're now going to explore a new operation. It might be fun if you can guess what the more formal name for this operation is by asking a different question. It's no longer which is larger. We've solved that problem, but it's the follow-up question, by how much? So we've established which is larger. And now what we want to do is we want to answer the numeric question of, well, we know which is larger, but by how much?
In this video, we're going to continue our development of operations through the asking of an additional question. You should remember at this point that we had earlier asked students to represent a number and then to represent another number. And the two numbers that we asked them to represent for the purposes of our example were 5 and 4. And because of numerical fluency, we should be able to represent them with words and then also with objects and with symbols. And so as I represented these two numbers using the objects, we made use of our subitizing and chunking because, again, we want our students to be able to recognize that a 4 will look like this when we're dealing with ones. We, of course, built visual representation for 4 tens, for 4 100s, and then the cycle repeats. So all we have to do is to visualize from 0 to 9 objects and remember the appropriate place value. I'm purposely keeping this fairly simple so that we can focus on the concept, but we could do this with any number in any place value just by representing each of the 0 through 9 digits in each of the place values represented by the number. The question that I asked after we had represented these two numbers was a very reasonable one, and it's one that young children would ask immediately, and that's which is larger. And we could tell simply by looking at them that this is larger. Visually, we can do the visual comparison, and we can see immediately. I showed you a little trick there in terms of putting a larger number of dots next to the larger number and then connecting the dots to generate a sign or a symbol to keep track of this relationship. And we could do it at the object level, we could do it at the symbol level. Because we are numerically fluent, we can go in between those two either way. Now, for the sake of simplicity down the road, I am going to have a standard process here where I put the larger number on the top before I ask another question. This is part of my organization phase, because not every problem is going to lend itself to being solved necessarily in the same way as what we see here, where we have things going left to right. Sometimes problems can be solved from top to bottom. It's just a question of how we choose to represent it. So if I record this so that it's recorded in both symbols and with objects, I can now ask another question. And this time the question I'm going to ask is a follow-up from which is larger. It is, by how much? And what we mean by that is, well, by how much larger is it? And the actions that young people perform in solving this can best be described by what I have called pairwise removal. That's P-A-I-R-wise removal. And what this means is that we take the same number of objects from each of the two groups until we can't do it anymore. So that's the pair. Here's our pair, is 5 and 4, and we're going to take the same number of objects away from each of the groups until we can't anymore. Now, because of the way we've organized, I can take 3 away from this group, and I can take 3 away from this group very quickly, can't I? And now I can take an additional 1 away from each group, and look what I have left. I have 1 left. How do we record that? Well, let's take a look. We already have our symbols in place, and so I'm going to put down a new symbol, and just for the sake of having a little fun with it, sometimes when I'm in the classroom, this gets to be called the do it dang it line. In other words, that's going to tell us to do something. And what it's going to tell us to do is to do a pairwise removal. So if I see a symbol that looks like this, it tells me I'm going to represent 5, I'm going to represent 4, I'm going to do it, dang it. Well, what is it that I am going to do? We're going to do the action of pairwise removal, and we show that action with this symbol. And of course, the operation that generates is that of subtraction. And so what we can do when we read this now, just like we would read a short story, is we say we have 5 objects, we have 4 objects, we do a pairwise removal to see which is larger, we do it, dang it, and we get 1 left. And now is a perfectly good time to say that when we do pairwise removal, we are doing the operation of subtraction. This would hold true for any number of place values. The only thing we have to make sure of is that the students recognize that sometimes they might have to ungroup. And that's the second verse of our song that we will learn not this week, but in our future lessons. So we now can read this type of thing so that it's not just something we memorize at the symbol level, but it has meaning for us. It tells us that we start by representing this number. We represent this number. We find out which is larger, and we put that number on the top. And the big reason we do that is we don't want young people to have to deal with negative numbers right off the bat. I have done it both ways. There's nothing wrong with going negative numbers in the early elementary grades. It just takes a longer time to develop the concepts, and I would rather spend the time focusing on this operation of subtraction. And then as we do the dang it, as we do it, we carry out this action that we can now read, and the answer has meaning for us. And what makes it even better is if all the parents see is something that looks like this is a piece of math that they understand and that they would be able to help their child with.